All right, I want to look at a slightly more challenging area between curves problem so that we can see what steps we need to take to solve it. So let's find the area of the region enclosed by the parabolas y equals x squared and y equals 2x minus x squared. Now, we know that the first one is a parabola that opens upward, and the second one is a parabola that opens downward. So we're going to have a graph that might look something like this. And we're looking for the region in between them. But to figure out what that region is going to be, specifically, we need to figure out the endpoints so we know where we're integrating. We need to figure out where they intersect. And so to figure that out, we can set them equal to each other. We need to see where x squared is equal to 2x minus x squared. Because if we can figure that out, then we know the x values where those two functions intersect. So I'm going to add x squared to both sides to get the x squareds on the left. That'll give us 2x squared equals 2x. And then I'm going to subtract 2x from both sides to get all of the terms on the left so that we can factor and figure out what those points are. So we have a GCF of 2x that we can factor out. That's going to be 2x times x minus 1 equals 0. And if we set each of those factors equal to 0, 2x equals 0 or x minus 1 equals 0, we end up with our 2x values, x equals 0 or x equals 1, and those are going to give us our limits of integration. So we know that the area of this region is going to be an integral from 0 to 1. And the thing that we need to integrate is the difference of the two functions, but we need to figure out which one is going to be the larger function and which one is going to be the smaller function. Now, in this particular example, because we know that our functions consist of an upward opening parabola and a downward opening parabola, it's going to have to look something like this, where the downward opening parabola is the upper function, and the upward opening parabola is the lower function. So in this case, the upper limit of integration is going to come from the downward opening parabola, which is going to be our 2x minus x squared. And then we're going to subtract the lower portion, which is the upward opening parabola, x squared. So it's going to look something like this. But maybe we don't know which is going to be our upper curve and which is going to be our lower curve, or maybe we've drawn it incorrectly. What we can do is we can pick a number in between our limits of integration and evaluate each of those functions at that number and see which is bigger and which is smaller. And that will give us the same thing. If we pick 1/2, which is between the two of those, if we look at y equals x squared, we've got 1/2 squared, which is 1/4. So the height of that function at that value is 1/4. If we look at y equals 2x minus x squared, that's going to give us 2 times 1/2 minus 1/2 squared. 2 times 1/2 is 1, and that's going to be 1 minus 1/4, which is 3/4. So we know that this is going to be the upper curve, and so that is going to be our f of x, and this is going to be the lower curve. That'll be the g of x that gets subtracted. And so we verified that this is the correct integral. So let's go ahead and simplify that integrand. We've got 2x minus x squared minus another x squared dx. That's going to be the same as 2x minus 2x squared. And then we can find that antiderivative. The antiderivative of 2x is x squared. And then we're going to have minus 2x cubed over 3 evaluating these at 0 and 1. And so that's going to be 1 squared minus 2 times 1 cubed over 3 minus 0. When you plug in 0 for those x's, you get nothing. And so we've got 1 minus 2/3, and 1 minus 2/3 is just 1/3, which is the area of the region in between those curves. So if we are not told what our limits of integration are, we're going to have to figure out where those curves intersect. And if we are not told which curve is the bound from above and which is the bound from below, we're going to have to look at the graph or do a little bit of math to figure out which is going to be above and which is going to be below our region.